Today we want to look at the Pythagorean trig identities. Now these identities are very, very useful not only in trig but also in calculus. And since you all are familiar with the term Pythagorean identity, let's go back and look at that basic Pythagorean identity that we've dealt with for years. And it always has to do with a right triangle. So if we have a right triangle, and then we will let this be our right angle, and we label this side x, this side y, and this side r, we know that that basic Pythagorean identity is x squared plus y squared equals r squared. And so that is an identity that we have dealt with for years and for years and for years. What we want to do is translate that identity and see how it works in regards to the unit circle. Now here I have a picture of a unit circle, and we know that in this unit circle we could drop a perpendicular from this point to the x-axis, and this would form my right triangle. If I do that, we can let from here to here be labeled as x. From here to here is our y value, and then our radius of the circle becomes our r. Our radius of a unit circle is always 1, so we can take this form of the Pythagorean identity dealing with right triangles and say that it is x squared plus y squared equals r squared, or 1, not r squared. We want to make that a 1 because we know that that is 1 squared. So x squared plus y squared equals 1 when we're dealing with the unit circle. Now here we have another form of the unit circle where we have identified x as the cosine of theta and y as the sine of theta. So if we substitute cosine theta for x and we substitute sine theta for y, we come up with a new identity, which is sine squared theta plus cosine squared theta equals 1. Now this is the primary Pythagorean identity. We use this one over and over and over again, but it also has two other forms, and so we want to take a few minutes to look at those two other forms. Now don't get worried about it. If you'll learn this one, you can always find the two other forms. We said our primary identity was sine squared theta plus cosine squared theta equals 1. If we take that identity and divide everything by sine squared, we have a new equation which becomes 1 plus, and then cosine squared divided by sine squared is cotangent squared theta equals cosecant squared theta. This is another form of the Pythagorean identity, and so this one is very valuable. We use it very often we have to use it for substitutions in proving other things. But the good thing about this is if you'll learn the first one, you can always find the second one. Okay, let's go back to our basic identity again. It was sine squared theta plus cosine squared theta equals 1. Now instead of dividing everything by sine squared, I want to divide everything by cosine squared. And here we get sine squared divided by cosine squared, which of course we all know is tangent squared. Anything divided by itself is 1, and 1 over the cosine squared theta is the secant squared theta. So this is the third form of the Pythagorean identity. Very important to know, but you don't have to memorize it. If you'll learn sine squared theta plus cosine squared theta equals 1, you can always come up with the second and third form of the Pythagorean identity. So our three identities are tangent squared theta plus 1 equals secant squared, 1 plus cotangent squared theta equals cosecant squared theta, and then the primary is sine squared theta plus cosine squared theta equals 1. Once again, let me stress, if you'll learn this one, don't spend a lot of time trying to memorize the other two. If you'll learn sine squared theta plus cosine squared theta equals 1, you can always go back and find the other two identities.